Hello, I'm Martin Hoerling. I'm a meteorologist in the Physical Sciences Lab, and I'm part of the Attribution, Predictability, and Assessments team. The work that I do involves looking at atmospheric processes that determine weather and the statistics of weather, which we call climate broadly. I'm especially focused on how these weather statistics are sensitive to ocean, sea ice, and chemical composition of the atmosphere. Give you a particular example of a study we recently did, and that was to examine a very unique pattern of changes in the wettest day of the year over the US, which have been going up substantially in the east and have been actually declining in the western US. So we've been trying to understand how that can be reconciled with climate change, with internal variability, and what it means for coming years. So it's relevant to the prediction problem itself. So by explaining attribution, we also tie into the concern of prediction. Going forward, I'll give you another example of something we are just beginning to spin up, and that is the Western drought, which began around 1999. It's called the Millennium Drought. The West has been under the gun, as you've seen in the media, of course, heat, fires, and there has been an absence of normal rains for over 20 years. So it's more than just hot droughts, it's that there have been an absence of rains with the heat at the same time. So part of our attribution activity is what's behind the precipitation deficit and the warmth. And part of the, as part of the assessment, we want to know, well, can we now predict when we think this drought will either weaken, go away, or maybe become more intense? So the time scale, again, drought time scale is a bit longer than extreme precip, but it's very relevant to decision making that has to look at the future and wonder as to whether there's a change in the statistics of weather patterns.